Welcome to this tutorial. Here I am going to explain about mechanics. Well, this is the branch of physics. We can write this is the branch of physics. And this branch of physics deals with the study of forces, and motion. Of course, it also deals with the relationship between forces and motion. So mechanics is a branch of physics which deals with the study of forces and motion and their relationship. Now, the study of mechanics is divided into three parts. Say, the first part is the statics. What is the statics? This is the branch of mechanics which deals with the object at rest. When the object is at rest. This statics is very important when we are designing bridge or the building, say bridges or the buildings, etc. We'll come to another branch, and the second one is called kinematics. This is the branch of mechanics which deals with the motion of object. Motion of objects. Alright? Without considering the cause of motion. Without considering the cause of motion. Well, this is very important that we are not considering the cause of motion. So here in kinematics, the size, shape, mass, etc., they don't matter. The kinematics is derived from the Greek word kinema. This comes from Greek word kinema, which means motion. Now we'll talk about the third part, and third part is dynamics. Well, this is the branch of mechanics which deals with the cause of motion. So, in dynamics, we study the effect of forces, which cause the motion. So, here mass of the object must be considered. Mass is considered. And we should know that this Greek word dynamics is derived from the word dynamis. This is a Greek word, dynamis, which means power. Now let's talk about two very important terms, and one is called rest. So, an object is said to be at rest if it does not change position, with respect to its surrounding, with passage of time. So if the object does not change, that means object is at rest. However, in case of motion, if the position changes with respect to its surrounding with the passage of time, that means the object is in motion. Rest and motion are relative. Rest and motion are relative to each other. Well, these are the relative terms. Say for example, I'm going to give you the example here. Just let me just scroll it up. Suppose this is a table and this table is kept in a room. So this room is in, say this is the room, and this room is on the earth. With respect to its surrounding, this table is at rest, right? But we know it very well, the earth rotates about its axis and also revolves around the sun. So if you are in this space, say there is a satellite here, you are in this space, this is the satellite, and you are standing here, you will see that the motion of the table also include motion of earth. So unless stated otherwise, when we discuss motion, we generally mean that it is the motion with respect to the surface of earth. Now let's talk about types of motion. Well, in general, the motion of the body can be of three types. One is translatory motion. So a body is said to have translational motion if each particle of the body, just let me write here the keyword, that each particle of the body has the same displacement in the same interval of time, has same displacement in the same interval of time. Well, in other words, this type of motion will have every particle of the body to cover a definite distance in the definite time in the linear path. Say this is a car and car is moving like this. Let's ignore the motion of the wheel, but the body of car will have translatory motion. Now there is a special case. If we are studying a single particle or point mass and it is moving in a straight line, this motion is called rectilinear motion. Rectilinear motion. The second type of motion is rotational motion. A body is said to have rotational motion or rotatory motion if each particle of the body except on the axis of rotation travels in a circle. So if it is moving like this, each particle of the body, that means so this is a rotational motion except on the axis of rotation. Can you guess why this axis of rotation is not included? Well, the rotation is in a straight line when we are talking about axis. So the motion at the axis will be in a straight line. Let's talk about the example. Suppose this is a door and we are opening or closing door. So all the point on the door will have rotational motion except the hinge, which is the axis. Now, if we are talking about single particle or point mass moving in a circle, this motion, single particle or point mass is moving in a circle, so this motion is called circular motion. Well, we'll talk about another one, and this is called oscillatory motion. Oscillatory motion. So a body is said to have an oscillatory motion if it moves to and fro about a fixed point. About a fixed point. And this fixed point is also called mean position. So here, let's take the example of a simple pendulum which is moving like this and like this. Simple pendulum goes like this, then come back like this, and it comes back like this. So it is having some oscillation, right? Now, if this distance is called, by the way, amplitude, this amplitude is extremely small. Extremely small. So this motion will be called as vibratory motion. Now we come back to the very important concept, and this concept is the concept of point object. Concept of point object or particle. We normally define a particle as an isolated point mass. Point object or particle is an isolated point mass. Here, let's emphasize on these terms. Having no size, and incapable of rotation. That means no rotation. So if we are having these three characteristics, we can call it as point object or particle. So, however, in reality, every object is going to take some space, will have some mass. So, can we treat a real object as particle? The answer is, well, it depends on the circumstances. So, let me give you some examples. In describing the motion of a car that is going 100 kilometers. So, suppose, let me just give this example. Suppose this is a car and it is going almost, say, 100 kilometers. So the length of the car is very small in comparison to the distance involved, and we can treat the whole car as particle. Similarly, suppose this is a simple pendulum and the bob is swinging like this and like this. We can consider bob as particle. Third, suppose you are traveling in a spacecraft towards the moon. Suppose this is a satellite and you are going to go towards the moon or any other celestial body. Well, the length of the spacecraft can be compared as particle. So the particle is not necessarily a very small object as commonly imagined. Rather, we take the particle to be simply an object that is small enough for its size, to be unimportant. That makes sense? Yeah. For the scale of our observation. Okay. So we are free to consider an object or a body as particle to simplify problems. So as long as we are able to simplify a problem, we can consider any object as a particle or point mass. Now we'll talk about location of objects. So let's talk about location of object. So we can specify the position in three-dimensional way. So this is the origin. Well, this is x-axis, this is y-axis, and this is z-axis. Let's talk about motion in 3, 2, and 1 dimensions. So in order to describe the motion of an object, we consider Earth as our frame of reference. Of course, later on we are going to study that Earth cannot be an absolute frame of reference. However, for practical purpose, we'll assume. So the first kind of dimension of this is three-dimensional motion, and the motion of an object in space is generally three-dimensional if all the three coordinates, that is x, y, and z, change with time. All the three coordinates are changing. So example is suppose aeroplane is flying or the bird is flying in the space. The next is two-dimensional motion is in plane. All right, and now let's talk about two-dimensional motion. Well, the motion of an object in a plane is two-dimensional motion. So here this is a motion in plane, and two of three coordinates, let's say x and y, are going to change with the passage of time. So here I'm going to give the example. Suppose we are throwing like this. This is a projectile motion, or some circular motion. That is the example of two-dimensional motion. Now we'll talk about one-dimensional motion. So motion of an object along a straight line, is one-dimensional. Only one out of three coordinates is going to change. Say for example, x coordinate is changing with the time. So motion of a train along this railway track, or vertical fall of the stone. Motion of a train or vertical fall. These kind of motion will come into this category. Now we'll talk about the physical quantities, which can be divided into two classes called scalar and vector quantities. So a scalar quantity is the one which is having magnitude only, but no direction, Well, example of the scalar quantities are, say, mass, length, energy, temperature, speed, etc. The magnitude or size of the scalar quantity is numerical value, and you need simple algebra for addition, subtraction, multiplication, and division. For such kind of operation, we use simple algebra. However, if we talk about vector quantity, these are the physical quantities which have magnitude as well as direction. All right. So, example of vector quantities are force, velocity, acceleration, and so on. Momentum. All right. For addition, subtraction, and multiplication, we need another algebra called vector algebra. Well, there is no division in that. And the vector can be represented graphically by a straight line like this. Here the length of the arrow indicates the magnitude, and the arrowhead indicates the direction. Well, say for example, if we are talking about force, so it can be represented like this, and the magnitude will be represented like this, F and modulus. And in print, it can be written as bold. Let me write just as bold symbol. So this is it for the time being. Next lecture I'm going to discuss about motion in a straight line.